Hello, everyone. My name is Pearl Uberu, and I'm a technical marketing engineer here at Databricks. And today I'm going to take you through a demo on how to use Fivetran to ingest data from Salesforce into your Lakehouse. After the data has been ingested, I'm going to show you how you can transform this data using dbt. Then we'll use Databricks SQL to query, visualize, and govern this data. Lastly, I'll show you how you can use AI functions in Databricks SQL to call language learning models. So without further ado, let's get started. I am currently in the Databricks workspace under the SQL persona. My manager has been having a hard time understanding our activities in the marketing department and would like to understand customer behavior, lead generation status, and how much revenue has been generated from our current deals and opportunities. The goal of this task is to make better decisions about our marketing initiatives by leveraging our CRM data in Salesforce. Clicking on the Data tab, I'm brought to my Data Explorer. This is where I have access to all my data. I've created a Unity catalog called Salesforce off-screen, and this is where I will ingest my Salesforce data. Hovering over the navy blue navigation pane to the left, click Partner Connect. Partner Connect makes it easy for you to integrate and use familiar data, analytics, and AI tools directly within the Databricks platform. We have a variety of ingestion and transformation tools, and in this part of the demo, I want to use Fivetran to ingest my data. Clicking on Fivetran opens up this window that connects Fivetran to Databricks. We can see that by default, the catalog has been already selected as Salesforce. Now, I'm going to hit Next and then connect Databricks to Fivetran. Then I hit Confirm and verify that the connection details, catalog name included, are automatically carried over from Databricks to Fivetran. Clicking on Save and Test allows Fivetran to check that the version of Databricks is compatible with Fivetran and that the cluster configuration is correct. Lastly, it validates permissions set by Databricks to access the compute resource. We are now good to go as Databricks is connected to Fivetran now. Let's now use our Salesforce connector. We do this by clicking the View Associated Connectors button. Then add connector and see that Databricks is the correct destination, but we want the data to come from Salesforce. So continuing setup, we're brought to a series of data sources that we can ingest from just a click of a button. Fivetran allows me to select and ingest data from more than 200 data sources. But for this task, I need data from Salesforce. Clicking Continue Setup, I verify the destination is still Databricks and within the catalog Salesforce. A schema will be created, and now I've titled it SFDC. As we continue, I'm prompted to allow Fivetran to access Salesforce and connect to it. The connection succeeded, and now to test the connection to the API. It's a success, so now we select our tables, and here I've selected Opportunity, Contact, and Account tables. Now to sync the data to our destination in Databricks. Since it's just a few tables, it doesn't take very long for the data to be synced. And now that it's complete, I can now check Databricks to make sure that my account, opportunity, and contact tables are in the specified place. In the Databricks workspace, within the Data tab, under the Catalog Salesforce, and under the Destination Schema SFDC, I can see my account table, contact table, and opportunity table. If I click within the account table, I'm able to see the column names, the data types of each column, and then I can see some sample data. Now, I'm going to show you exactly how to transform this data using dbt. Now that we have all of our data and tables loaded into Databricks, I'm going to show you how you can use dbt Cloud to develop this data, deploy it, and document it as well, so others in our organization know what assets we are creating within Databricks. To do this, let's head over to Partner Connect again and select dbt. dbt is a transformation workflow tool that allows you to quickly and collaboratively deploy analytics code following software engineering best practices like modularity, portability, CI/CD, and documentation. Clicking on DBT will start up a DBT Cloud account that is connected to your Databricks instance. For the sake of this demo, I've already set up this connection. To develop in DBT Cloud, I will click Develop and pull up the DBT Cloud IDE. The IDE is a great place for where we will do transformations on our data. The IDE is automatically connected to version control, so any changes that you make to your data in the IDE are pushed to your version control. This is great because it helps users develop with data while following software engineering best practices. First, we will stage our sources. To do this, we will set up YAML files, which is basically a connection to the data sources in Databricks. And this tells DBT where to look when it pushes the transformations down to Databricks. There are also descriptions and tests, so every time the workflows run, we can check for unique or not null or any complex test you can write in SQL. DBT can test. Next, we will build out the staging layer. Here we have staging tables, which are low transformation opportunities such as renaming columns or changing data types. We will take all the tables and stage them as views in Databricks and transform them in a more digestible format. Here I have my account table, and you can see that I've configured this to be a view in Databricks. DBT offers a lot of awesome configs to get started. So right now it's a view, but you can have a table, an incremental materialization, and really however you want to strategize, DBT allows you to do that. Once we have that data staged, I can then create another silver table in DBT Cloud. This will be my opportunities and accounts table that are combined and joined. Now I can start building out my gold tables. Let's say my manager wants to see an opportunities by region. This is the final table that I can have, and then build an opportunities dashboard on top of that. Once all the code is built in DBT Cloud, I can go ahead and click Build. This will build all upstream and downstream models. DBT is managing all dependencies based on how we use the references, so there's no need to worry about that as a developer. Now, I'm back in my workspace. I'll show you all the tables inside of my development environment. So here, I have my opportunities by region table and all silver layer views and tables. And now I'm ready to deploy. To deploy, all I need to do in DBT is create a job. A job is an instance of running one of the lineage graphs on a set cadence. I can also edit my daily refresh job, and I can set this on a schedule at 4 a.m. on Wednesdays or as an API call. Once I have my job set up, all of my data will be in my production environment. We developed in our development catalog, and we will have all of our jobs running in our production catalog for CI/CD purposes. This is to make sure that we are not developing in production and vice versa. I have my gold layer and my opportunities by region table produced for me to use for my analysis and for my manager's task. Now that we have our tables ready for analysis, let's start querying, visualizing, and creating a dashboard using Databricks SQL. Databricks SQL workloads such as queries, dashboards, and visualizations are powered by a compute resource called a SQL warehouse. SQL warehouses allow you to run SQL commands on data objects within Databricks SQL. For this demo, I'm using the DBT Cloud warehouse that I created off screen. Let's take a look at how the warehouse was set up. And the type of warehouse we are using in this demo is our serverless warehouse. Serverless warehouse includes increased performance features such as fully managed elastic compute and high concurrency. Selecting advanced options, I'm able to see that Unity Catalog is enabled by default for this warehouse. This will allow me to access Unity Catalog data and run Unity Catalog specific commands by default. Now that my warehouse is running, let's head back to the Data Explorer tab. I can see different catalogs, but specifically, the Salesforce catalog was created to ingest data using Fivetran via the Salesforce connector. The development and production catalogs were created to collect development and production data from DBT respectively. Within the catalog, I can see that I have 4 schemas: default, gold layer, information schema, and silver layer. I can see details surrounding the catalog, and I can grant permissions to users or groups on the catalog. I will give use permissions to my manager just in case. Within the gold layer schema, I can now see my opportunities by region table that I created within DBT. I can see details surrounding the schema, and I can grant permissions to users or groups on the schema as well. Within the opportunities by region table, I see the column name and data types for each column. But I want to see what this data looks like. The sample data tab allows me to see what my data looks like without running any code. And similarly, I can grant permissions and privileges to users and groups at the table level. This is the power of Unity Catalog at work. Let's start querying this data. In the SQL Editor tab, I can create a new query. Let's create one. But first, I'd like to quickly reference column names and data types within my table. So let me adjust the schema browser to the appropriate catalog, schema, and table name. This will make writing our queries easier. Now I can begin. Autocomplete within the SQL editor significantly cuts down the time to write queries efficiently. Within this query, I can now create a visualization. Let's create one by clicking the plus button and then clicking the visualization button. At the top here, I can see that I can change the visualization type to a variety of charts and graphs, but I'll keep the bar chart for now. The X column will be the account state, and the number of opportunities will be the Y column. Before I hit save, I'll change the titles of the axes of my chart to something more appealing and easy to read: state and number of opportunities. Lastly, I'll rename my visualization as opportunities by state. Now that my visualization has been created, I'm going to add it to a dashboard. I'm going to create a dashboard that is easy for my manager to digest. I'll call it the Opportunities Dashboard. Now I can add the visualization I created. Off screen, I generated more queries and created visualizations and added them to create a final product that I think my manager would like. I will schedule it to refresh every 24 hours, and I'll share the dashboard with him and give him access to manage and edit the dashboard if he wishes. What if my manager wants to know details about the table and how it was used to generate the dashboard? That's super easy. Let's head back to the Data Explorer tab. First my catalog, then my schema, and then my table. I can hit this lineage button here and then click Dashboards. I can see the dashboards that I've created using the specified table. And I can see the lineage data captured when I ran my queries using the Opportunities by Region table. But that's not all. If I click Tables, I'm able to see the tables I've used upstream and downstream. I can see how it all ties together by clicking this lineage graph. As you can see, my production silver layer staging tables for account opportunities that I created in DBT was transformed into the Opportunities by Region table. But if I click the plus sign, it expands my lineage, showing me the staging tables that were created in DBT all the way back to the account and opportunity tables that were ingested from Salesforce using Fivetran. If you click into the actual tables, you're able to see the column, data types, and lineage associated with the table. This is the beauty of Unity Catalog and data lineage. Everything is traceable and everything is permissioned. Now, let's make things a little bit more fun. With the incredible progress being made in the space of large language models, Databricks SQL has built in AI functions that allow you to access LLMs directly from SQL. Let me briefly show you how to do this using the Azure OpenAI service as our LLM. In future releases, we'll enable other large language models, including open source LLMs such as Dolly. My manager has shared that the analyst team spends copious amounts of time trying to sort through a column of data that houses descriptions about the companies we have opportunities with. He believes that it is becoming much more time consuming and complex as the company descriptions become more detailed. I introduced him to the idea of leveraging LLMs to help resolve this issue. First, I create a function that classifies the description column and wrap that using the AI generate text function. It would be great to reduce the amount of time the analysts spend reading or analyzing these descriptions, and so I feed it the prompt, please provide a 5-word summary of the following. Now that my function has been created, I can now feed it a description and see the 5-word summary generated for a company called The Edge. My manager is thoroughly impressed and believes that sorting through 5-word summaries instead of these long descriptions would be much easier and would free up the time of our analyst team. This is just a small example of the capabilities Databricks has to resolve complex and cumbersome issues using AI functions in SQL. And that's really it. So, to recap, I created a Unity catalog called Salesforce, and then I ingested sales data from Salesforce using the Fivetran Salesforce connector. Then I used dbt to transform this data into a clean and usable format. After, I set up my SQL warehouses and I was able to query the data, create rich visualizations, and then add them to a newly created dashboard, all right here on Databricks. Through it all, I was able to govern my data objects and track changes to my data, whether it was ingested using Fivetran, transformed using dbt, or queried and visualized on Databricks using data lineage. Lastly, I showed you how AI functions can be leveraged through Databricks SQL to quickly experiment with LLMs on your company's data. I hope you enjoyed this demo, and I hope you feel encouraged and empowered to get started using Databricks for your analytics, warehousing, and AI needs.